Our today's topic is electric lines of forces. In my previous topic, I have discussed about the electric field. When a charge is placed, always around it, an electric field is there. If any charge is placed within that field, it is going to experience the electrostatic force on it. And if that charge is free to move, then I'll make it in a diagram. Suppose this is a charge Q, it is placed here. Around it, there will be the electric field. Where the charge is close, the electric field will be maximum. As it is moving away, as the distance is moved away from this charge, the electric field will keep on decreasing. There is a gradual decrease in that. If within this field any other charge, say Q naught charge, is being placed, then there will be the electrostatic force between two of them. And if this charge is free to move, then it will be following the path that is along the direction of the electrostatic force. This Q naught charge is going to follow the force that is electrostatic lying between them, this Q naught and Q. And if this electrostatic force, it is continuously changing, then Q naught is going to follow the curved path. So whatever the path that is followed by this charge is being traced. Hence, from our discussion of the electric lines of force, we conclude the definition of this electric line of force, it is imaginary. Actually, it is not existing there. We have just traced the path of the charge particle in the field of the charge particle that is placed, and the direction is the electrostatic force. So these are the smooth curves that are drawn in electric field, along which a free isolated positive charge is going to move. So this is the one thing that is going to give us the uh, type of the lines of forces that a type of the charge is going to follow. It is depending on the electrostatic force. Now, the second thing, this one is the second thing. The tangent drawn at any point, whatever the lines of forces are there, at any point on that line of forces, we draw a tangent. It is going us to give the direction of the force acting on a positive charge placed at that point. So these are the two important things. Depending on that, we will be having there will be the properties of electric field lines, and along with the help of this, we can find out what is the nature of the lines of forces depending on what charge we have taken. Based on the definition, how we are going to trace the electric lines of forces, we will apply it to find out the lines of forces for the positive. This is the positive charge and this one is a negative charge. Now we have considered positive test charge. It is conventional that we use to take positive test charge. On placing it, and it is free to move in the field of this positive charge, we find out that there will be the force of repulsion between the test charge and this positive charge. Because of that repulsion, that will be moving in the outward direction, and because of that, these lines of forces are directed in the outward direction, and they are the straight lines in the nature. On the other hand, when the positive test charge is placed in the electric field of this negative charge, in that case it is going to have an attractive effect on it, and because of that, the lines of forces, these are the imaginary lines, this is just following the path that the test charge is going to follow under the electrostatic force. So that is in the inward direction. So this is the lines of forces are for the positive and the negative charge. For positive charge, they are radially outward, and for negative charge, they are radially inward direction as shown in the figure. Now we are going to find out the electric lines of forces for the two type of the charges. One of them is positive and another is negative. If the magnitude of these positive and negative charges are equal, then it is considered that they are forming a electric dipole. Electric dipole is a arrangement in which two of the charged particles of same magnitude but they are opposite in nature, that is one is positive and negative, are separated by a small distance. Now we have seen that in positive the lines of forces are in outward direction and in negative they are in inward direction. So if you look at the figure, the lines of forces that are traced, they are forming like if the lines of forces are originating from the positive and they are being terminated on the negative charge. One more important thing is there, that in the region where positive and negative charges are placed near to that, the electric field is strongest and hence the concentration of the lines of forces will be more here. Now, and the region where this is less, the lines are having more distance between them or the concentration is weaker in those areas. Now, the next is the electric lines of forces because of the similar charges placed together. Here, these two charges of equal in magnitude, and we can see for the positive charge, the lines of electric lines of forces are radially in the outward direction. These are curved because of the effect of the repulsion between two of them. Now you can see there is a point N. This N point is at the line joining these two charges and it is at the midpoint. Now at this point in, there will be the electric lines of forces from both of them that are in equal magnitude but opposite in the direction, and they are going to have the resultant effect zero. That is why there are no electric field lines over here, and this point is known as the end point where there are no electric field lines around it, is known as the neutral point. Here the lines of forces for two equal and similar positive charges we have taken here at the midpoint in, that is lying at the line joining between the two charges, the field produced by one charge is equal and opposite to the field produced by the other charge. This type of condition you will have many times in the derivations or in the numericals too, where whenever the electric fields lines are equal in magnitude and opposite in direction, they are going to produce the resultant zero. Therefore at this point the resultant field is zero and there are no electric lines of forces. Because of that, there is the absence of that, and this N is called the neutral point. Suppose there is a long line of the charges, we have taken the positive charges here, then the electric lines of forces comes out to be parallel to one another as shown in the figure. There are two plates of charges, one is having positive, another is having negative. As such, the electric field lines originate from the positive and it terminates on the negative plate. Now there is one change in the nature of the electric field lines. You can see this is parallel between the plates, and at the edges it is having a bit curved path. So it is being seen that at the central region where these plates are lying, that central region is having uniform electric field and the lines are parallel, and at the edges these are showing that the electric field is not uniform there and it is showing the fringes there. So this is the nature of the electric field lines in the case of two opposite charge plates as shown in the figure. Now we are going to discuss about the conclusions or properties of electric field lines that we have discussed. Among that, the first one is the electric lines of forces. They start or originate from the positive charges and terminate on negative charges that we have seen in the figure 2. Second point is that the tangent drawn at any point, the electric field lines are lying. If we at any point we draw the tangent, it is going to give the direction of the electric field. The tangent drawn at any point on the line of force, it is going to give the direction of the electric field. Now, this is a very important thing, and many times conceptual question is being asked from that. why the we have drawn those lines of forces, and we have seen that none of them is intersecting each other. The lines of force cannot intersect at a common point. What is the reason behind this? If because the direction is given by the tangent drawn at any point, if there the two lines will cross, then there will be the two tangents drawn at those points, and it is going to give the two directions of electric field. That is not possible. For if they, then two different directions means two tangents of the electric field will be there, and this thing is not possible. This is not going to happen. So this is the reason that two lines of forces can never intersect each other. Then the next property is the electric field lines. They do not pass through a conductor. Electric field lines inside a conductor is not there. It means, what it means, that electric field is not there because lines of forces are drawn within the electric field. It means electric field lines and electric field inside a conductor is zero. The next important thing is we can just see, we can look at the electric lines of forces, and from there also we can tell about the nature of the electric field. If the lines of forces are very close together, बहुत पास पास हैं, the closeness of electric field, it means it is having very strong electric field. If there is a gap between them, spaced or apart electric field lines, they always show the electric field is weak there. The next property is the lines of force have a tendency to contract in length. The contract, if many times a conceptual question is being given, their nature of charges have not been there. But just you have to look whatever is the nature of the electric lines of forces. From there you have to identify what is the nature of the charge. In that case, these points are very important. If the lines of forces have a tendency to contract, contraction will happen only when these two charges are opposite in nature. So they are contracting in length like a stretched elastic string. This explains the attraction, and attraction is between always the opposite charges. The next property is if the lines of forces somewhere are being shown with a tendency of separation from each other. So you know very well that separation exists when there are the like charges. So whenever the lines of force have a tendency to separate from each other in the direction to their length, this explains the repulsion between the like charges. So just looking at the lines of forces, whether they are contracting or they are have a tendency of separation, you can identify the nature of the charges there. The next important, this is also very important conclusion, this is the lines of forces are continuous. You have seen, you have drawn those lines of forces, none of them is having break between them. Actually these electric field lines, they are showing the electric field. Electric field lines are imaginary but electric field is real. Since it is existing, that is why the lines of forces won't have any break on them. The lines of force are continuous. They are not having any break between them. This is because electric field lines represent electric field through they are and imaginary. Though they are imaginary, though electric lines are imaginary, but electric field is real. So this is all about electric field lines, and the next topic we have completed of the properties of electric field lines. So this is all for today.